Hello, everybody. On this episode of Magnificent Conversations, our special guest, the exponent rules. In this video, I'm going to go over simple one-step simplification of exponents. Then I'll do a medium skill level, and then I'll do a hard skill level. So listed, I have all the exponent rules that we'll use in this first video. If I have an x by itself, I have to remember that the exponent is an invisible 1. Anything to the 0 power is equal to 1. If I have something to a -1 exponent, I flip it or take the reciprocal. Same thing if it's to a negative number, it's the reciprocal of that. If I have xy to the -1, again, I take the reciprocal, so now it's y over x. If I'm multiplying two exponents with the same base, so x to the m times x to the n, I add the exponents. If I'm dividing and I have the same base, I subtract the exponents. If I have a power to a power, I multiply the exponents. So x to the m and then to the nth means multiply the exponents. Exponent rules is something you just have to practice until you master. Watching me is not enough. You need to do as many problems as possible. So I'm going to start off with simple one-step ones. So x squared times x to the 5th. Bases are the same. Multiplying means I'm going to add my exponents. So if I have x to the 2nd times x to the 5th, that's going to turn into x to the 2 plus 5, which is x to the 7th. So let's try y to the 4th times y. Okay. I have the same base. Both bases are y, and I'm multiplying, so I know I'm going to add my exponents. Y to the 4th. If my exponent is invisible, I remind myself it's a 1. So y to the 4 plus 1 is y to the 5th. Okay, next example, x plus 3 squared times x plus 3 to the 5th. In this case, the base is the x plus 3. X plus 3, the x and the 3 are married to each other by the plus sign, so you do not distribute the exponent in. That is one term. So x plus 3 squared times x plus 3 to the 5th. I'm multiplying. My bases are the same, so I'm going to add my exponents. So that's going to be x plus 3 to the 7th. AB to the 3rd times AB to the -3rd. My base is AB, and I'm multiplying them, so I know I'm going to add my exponents. 3 plus -3. 3 plus -3 is 0, and anything to the 0 power is 1. Okay, x to the -8th times x to the 7th. My bases are the same. I'm multiplying, so I know I'm going to add my exponents. -8 plus 7 is -1. I know if I have x to the -1, it becomes the reciprocal, so my answer is 1 over x. Let's continue with some more one-step problems. So x to the 9th divided by x to the 6th. Bases are the same, and I'm dividing, so I know I'm going to subtract my exponents. X to the 9 minus 6 is x to the 3rd. Y divided by y to the third. Bases are the same, they're both y. I know if the exponent is invisible, it's a 1. So I'm going to put it there. So this is y, 1 minus 3. 1 minus 3 is negative 2. And we know if our exponent is negative, our answer becomes the reciprocal. The next one is where things get a little tricky and you just need to be very meticulous when the exponent in the denominator is negative. So my bases are the same. I'm dividing, so I know I subtract my exponents. So this is going to be 5 minus negative 2. We have to remember when we have a double negative, we supercharge it to a positive. So this is really x to the 5 plus 2, which is x to the 7. Okay. X minus 2 to the negative 5th divided by x minus 2 to the negative 5th. My bases are the same, it's x minus 2. I'm dividing, so I subtract. X minus 2 to the negative 5 minus negative 5. Again, double negative means we supercharge to a positive. So this is x minus 2 to the 0 power, and anything to the 0 power is 1. Okay. AB to the 7th divided by AB to the negative 3rd. My base is the same. They're both A times B. We're dividing, so we subtract. So this is AB to the 7 minus negative 3. Again, double negative supercharges to a positive. This is AB to the 10th. Now we see our rule over here, that's a power to a power. So that means this 10 has to distribute in A to the 10th times B to the 10th. All right, let's finish up our one-step problems. I have x to the 3rd squared. This is a power to a power. When I have a power to a power, I multiply. So this is x to the 3 times 2, which is x to the 6th. Y to the negative 5th raised to the negative 3rd. Power to a power, so I multiply. So negative 5 times negative 3 is y to the positive 15. X plus 1 raised to the negative 1 raised to the 3rd power. So power to a power, so that's x plus 1 to the negative 1 times 3, which is x plus 1 to the negative 3. Again, negative exponents mean we need the reciprocal, so it's 1 over x plus 1 to the 3rd power. AB squared means that everything inside, because everything inside is being multiplied, I distribute that exponent. So this is a squared times b squared. Pay attention between the last example and this example. If there's a plus or minus, you do not distribute in the exponent. If the things inside are multiplied or divided, you do distribute in the exponent. Okay, 3x squared to the 4th power. Again, I have two things inside here that need the exponent. So this is 3 to the 4th times x squared to the 4th. Power to a power means we multiply. 3 to the 4th is 81. X to the 2 times 4 is x to the 8th. In the next video, we're going to ramp it up and do some multi-step simplifying problems. So make sure you check that video out as well.